Okay, so I'm going to now go into unit circle and look at the unit circle. We're going to look at what the unit circle is, how do we develop an equation, and how do we generate special points all around the unit circle. And I'm going to do this in a two-part lesson. So in general right now, this is the equation of a circle in general. So this is the general equation of a circle. What this means is that if I have any circle that has a center point at h and k and a radius of length r, the equation of my circle is going to be x minus h squared plus y minus k squared equals to r squared. That's my general equation. So in this chapter here, we're not just dealing with any circle, we're dealing with a unit circle. And a unit circle is a special circle that is centered right at 0. So I'm going to take this center and I'm going to slide it down to the origin at 0, 0. And I'm going to take my radius and I'm going to make it a radius of 1. So this is a specific circle. And I want to come up with the equation of this specific circle. So this one has a center at 0, 0 and a radius equaling to 1. So what I want to do is I want to substitute my center point 0, 0 for h and k and substitute my radius 1 for r squared. So in doing that, I have x minus 0 squared plus y minus 0 squared equals to 1 squared, and then just cleaning that up, x take away nothing is just x, y take away nothing is just y, and 1 squared is 1. So let's put that all together into this equation. So what that tells me is that this particular circle has this equation, x squared plus y squared equals to 1. Now this specific circle has a special name, and that is the unit circle. So the unit circle is a circle centered at the origin, 0, 0, with a radius of 1. And we've just seen the equation of that unit circle, x squared plus y squared equals to 1. So let's work with this equation a little bit, and let's look at how we can put it into our calculator. So if we have x squared plus y squared equals 1, on your calculator, the only equations we can put in are a y equals equation. So what we need to do is isolate y. So I'll do that by subtracting x squared from both sides. So I get y squared equals 1 minus x squared. And then I want to take the square root of both sides to isolate for y. So remember, when you take the square root, you have to have a positive and a negative answer. So this would end up being that y equals to plus or minus 1 minus x squared. So the plus or minus just tells me that there are two equations. So in y1, I can enter in the positive root, and in y2, I can enter in the negative root. So I can put that all into my calculator, and I can get an equation, or sorry, I can get a graph of the unit circle. So let's look at that in the graphing calculator. So I just, because my radius was 1, I just compressed my windows to be from -3 to +3 for both x and y. And there is my unit circle. So it's centered right at the origin, and it has a radius of 1 unit in all directions. So putting that into the calculator can help us, because then we can verify if points are on the calculator graphically. Let's look at doing such a question, but we'll do it algebraically first. So is this following coordinate on the unit circle? So if it is on the unit circle, it will satisfy this equation, x squared plus y squared equals 1. So plugging in x and plugging in y, using brackets for my substitution, and then I'm just going to work this out. So 4 over 5 squared, well, 4 squared is 16 over 25 squared is 25, plus -3 squared, that means -3 times -3, which is actually +9, which is why my brackets are important, and then 5 squared is 25. So I want that to equal 1. So both of these denominators are out of 25, so I know that 1 can be written as 25 out of 25. So then I add these together, 16 plus 9 is 25, and since 25 out of 25 equals 25 out of 25, yes, this point is on the unit circle. So I've verified that graphically. Let's just check, or sorry, I verified that algebraically. Let's check graphically. So in my graphing calculator, I have my equation, and then I check to see, I did a trace 4 over 5, and I see that the y-coordinate that goes with that is in fact -3 over 5, so I can see it passes through the unit circle. Let's try another one. So I want to know if this one's on the unit circle. So x squared plus y squared equals 1. So using brackets, substitute your x and y values in, and then we're going to work it out to see if it equals 1. So 5 squared is 25, 8 squared is 64, 3 squared is 9, 8 squared is 64. The denominators are out of 64, so I'll make 1 64 out of 64 just to see if it matches. So on the left hand side I do 25 plus 9, and that's 34 out of 64. And you can see that is clearly not equal. So no, this point is not on the unit circle. So I've checked that algebraically. Let's verify it graphically. So again, there's my unit circle, and you can see the point 5 over 8 and 3 over 8 not on the unit circle. It's in the middle of the unit circle, on the inside of the unit circle, so it's definitely not on the unit circle. Okay, let's take this idea of the unit circle, and now we're going to find specific points on the unit circle. So for example, if this is a point on the unit circle, we're told it's a point on the unit circle, we want to find the value of y that goes with that. So let's go always back to our equation. Since it's on the unit circle, I know it verifies this, or it satisfies this equation. So x is a half, y we don't know, equals 1. So 1 squared over 2 squared. Now I see the denominator's out of 4, so I'm just going to write 1 as 4 out of 4, so it has the same denominator. And then to get y by itself, I will subtract a quarter from both sides. So a quarter take away quarter is 0. Y squared equals 3 out of 4. So I'm going to square root both sides. Now remember that tip that I gave you guys when we were isolating y to put it in the equation. When you take the square root, it has to be plus or minus. Now since it's a fraction, I'm going to do the square root of the numerator over the square root of the denominator. So I get plus or minus root 3 over the square root of 4, which is just 2. So plus or minus means there are 2 coordinates. So one coordinate would be 1/2 and positive root 3 over 2. And another coordinate would be negative root 3 over 2. Okay, and that makes sense because the circle is symmetrical. So when x is a half, there are 2 y coordinates, one above, one below. So I have these points algebraically. Let's just check graphically if they are actually on the unit circle. So when I do trace of 0.5, I get this number, which when I check on the calculator, root 3 over 2 is equal to the same number. So I know that one's correct. And then when I do trace of 0.5 on the bottom half of the circle, I get the same thing but negative. And negative root 3 over 2 again has the same value. So I know that these are the same, so they are both points on the unit circle. Okay, let's try this one here where they're being specific. They don't want to just find points, they want to find a specific point in quadrant 3. So it's on the unit circle, it has coordinates of x and negative 1 over root 2. So since it's on the unit circle, I know it satisfies this equation. So let's plug in y, again using brackets, equals to 1. So x squared plus negative 1 squared is negative 1 times negative 1, which is positive 1. Root 2 squared, root 2 times root 2 is the roots cancel, or you can say it's root 4, and the square root of 4 is 2, equals 2. Now instead of 1, since it's out of 2, I'll just write it as 2 out of 2, just to make my fractions a little easier. So I'm going to subtract a half from both sides to get x squared by itself. So a half take away a half is 0. So I have x squared equals 2 over 2 take away 1 over 2 is 1 over 2. So to get x by itself, I'm going to square root both sides, remembering that when you take the square root, it's always plus or minus. So x is equal to plus or minus the root of 1 over the root of 2. So x is equal to plus or minus 1 over the root of 2. Now normally I would want to rationalize that denominator, but since the original question was not rationalized, I'm just going to leave it. So plus or minus means there are 2 coordinates. So I have 1 over root 2 with negative 1 over root 2, and I have negative 1 over root 2 and negative 1 over root 2. So it looks like I have 2 points, but they said they want the point that's in quadrant number 3. So I know in quadrant number 3, all of my coordinates are negative and negative. So I know that this is my coordinate that I'm looking for. The other coordinate, 1 over root 2 and negative 1 over root 2, this one is in quadrant number 4. So I'm not going to use that one. So there would just be one answer, which is in quadrant 3. So now that I've done that algebraically, I always like to verify things graphically. So in my graphing calculator, since I had my y value of -1 over root 2, I did the intersection method, y1, y2 intersect. So I can see that the first intersection point is at -0.7, which is the same as 1 over root 2. They're the same thing. So I know that that is correct. You can see that my other point is correct. It is on the unit circle, but since it is in quadrant 4, so 1, 2, 3, and 4, since it's in quadrant 4, I don't use it. I just use my one that is in quadrant number 3. Okay, so we're going to depart from unit circle for a minute, just back to special triangles in 20-1. So hopefully this is all just a review. Okay, so there were 3 special triangles that we looked at. We looked at the 30, 60, 90 triangle, where the base angle is 30 and where the base angle is 60, and the 45, 45, 90 triangle, where the base angle, well, it could be 45 or 45, they're the same. So we really need to commit these to memory, and hopefully you've memorized them since 20-1. What I would tell my students here is that the 30, 60, 90 triangle is easy as 1, 2, root 3. So that's how we remembered the sides, 1, 2, root 3. And if you ever want to have a tick to see where each of those sides go, well, 2 is the biggest number, so 2 has to be the hypotenuse because it's the biggest. And then if you want to know where the 1 and the root 3 is, what I always used as a trick is that the root 3 and the 30 degrees are always side by side. They're adjacent to each other. Okay? The 45, 45, 90 triangle, that's 1, 1, and root 2. So what I told my students to memorize that is that 45, 45, 90 is isosceles because we have equal base angles. So if we have equal base angles, we have to have equal sides. So those are the 1 and the 1. And then 1 squared plus 1 squared is 2. So it's just 1, 1, and root 2. So whatever way that you memorize that, we want to have these committed to memory. So what on earth does this have to do with the unit circle? I want to take these triangles one at a time and I want to make them fit into the unit circle. So here I have this 30, 60, 90 triangle. I want to make it fit into the unit circle. Now, what we know about the unit circle is that it has a radius of 1. So right now, this triangle, if I put it in, the circle would have a radius of 2. So how do I go from a radius or a hypotenuse of 2 to a radius or hypotenuse of 1? Well, to go from 2 to 1, I would divide both sides by 2. But if I did that to the hypotenuse, to be fair, I have to do that to the adjacent and also to the opposite. So I'm going to take this triangle, putting it in here by making it half the size. So this side here of root 3 becomes half the size. It becomes root 3 over 2. And this side here, the opposite of 1, becomes its half of that size, which is a half. So this triangle hits the circle at the point 30 degrees, because I can see it's a 30-degree angle, and it has coordinates of x, y. Well, now looking at my triangle, I can see that along the x-axis, the coordinate would be, or the x value would be root 3 over 2. And for my y-coordinate, along the y-axis vertically, it would have a y value of a half. Well, let's see how those tie together. So from 20-1, we know on our 30, 60, 90 triangle, using SOHCAHTOA, cosine is root 3 over 2, sine is a half, and tangent is 1 over root 3. So if we look at cosine is root 3 over 2. Well, look what else is root 3 over 2, the side x. Sine is a half. Well, if you look over here, that's the y value. The y value is also a half. Now, what about tangent? Tangent is 1 over root 3. How can I relate those together? Well, if I look at, I'm trying to find a 1 and a root 3. If I look at my numerator of this guy and divide it by my numerator of this one, I get tangent. So what looks like is happening is that cosine of 30 is my x-coordinate. Sine of 30 is my y-coordinate. And it looks like tan of 30 is sine of 30 divided by cosine of 30, the 1 over the root 3. So looking at this from a 30-1 perspective, in our unit triangle, we can actually see that cosine of 30 is my x-coordinate, sine of 30 is my y-coordinate, And tangent is, well, I said it was sine over cos, but look what sine is. Sine is y and cos is x. So it looks like, yes, tan is y over x. So what we're going to do is take this unit triangle that was derived from our 20-1 triangle, and we're going to place this in the unit circle all the way around the unit circle. Okay, so starting at the unit circle, we have our very first one that has a reference angle of 30 degrees. So this one here, reference angle of 30 degrees. So I know that my first point on the unit circle, when x is 30 degrees, is going to be the coordinates root 3 over 2 and 1/2. So that's my first one. So what I'm going to do is I'm going to take this triangle, and borrowing from chapter 1, we're going to do some reflections all the way around the unit circle. So we're going to take this triangle here, and we're going to do a horizontal reflection in the y-axis. So we reflect it over there. So remember, when we do a horizontal reflection, all of our points x, y become the points negative x, y. And you can see that's exactly what's happened. My x coordinate is negative, my y coordinate stays positive. So I know that my coordinates are negative root 3 over 2 and 1/2. Also, because it's in quadrant 2, that also fits. Quadrant 2 has coordinates that are negative and positive. So what we have to do is figure out what our angle is. So a 30-degree reference angle in quadrant 2. To figure out what my angle is, I'm going to do 180, take away 30, because I haven't reached 180 yet. I'm 30 degrees short. So this point would be 150 degrees. Okay, so what I'm going to do now is I'm going to take this triangle and I'm going to reflect it vertically in the x-axis. So reflecting it vertically, I know that all my xy points become x negative y points when I reflect something vertically. So let's look at that. So reflecting this triangle vertically, I can see that yes, my x stayed the same and my y became the opposite value, 1/2 to negative 1/2. So I know that my coordinates here are going to be negative root 3 over 2 and negative 1/2, again fitting with quadrant 3. In quadrant 3, all of my coordinates are negative, negative. So all I have to do now is figure out what my angle is. So if I've gone around from 0 all the way to 180, I'm going an extra 30 degrees. So my angle will be 180 plus 30 degrees. So this point on the unit circle is 210. Okay, for my final triangle here, I'm going to take this triangle and I'm going to reflect it horizontally in the y-axis. So when I reflect something horizontally, all of my xy points become negative xy points. So x becomes the opposite value, y stays the same. So reflecting that triangle, you can see that my y values stayed the same, negative 1/2, negative 1/2. My x values were opposite. So negative root 3 over 2 became positive root 3 over 2. So my coordinate here will be root 3 over 2 and negative 1/2. Again, fitting with quadrant 4, where our points are always positive and negative. So all we have to do is figure out what my angle is. So starting at 0, I went all the way around, almost to 360, but I was 30 short. So to figure out what my angle is, I do 360 take away 30, and I know that my coordinate is 330 degrees. So through reflections and figuring out our angles, we now have 4 points that are on the unit circle. All of these points satisfy the equation x squared plus y squared equals 1. And again, specific to the unit circle, all of my x coordinates are the cosine of the angle. So we now know what cos of 30 is, cos of 150, cos of 210, and cos of 330 in exact values. The y coordinates are sine. So I now know sine of 30, sine of 150, sine of 210, and sine of 330 degrees. I can also figure out what tangent is just doing the ratio. So since the denominators are all the same, I know that tan of 30 is y over x, 1 over root 3. Over here, tan of 150 is y over x, so that's 1 over negative root 3. Over here, tan of 210 is y over x, so negative 1 over negative root 3. These are all unsimplified. And then tan of 330 degrees is negative 1 over root 3. I would just have to simplify those and rationalize the denominators, but you get the idea of how to figure out tan. So what I want you to notice here is that each coordinate in this unit circle here with 30-degree reference angle is all root 3 over 2.5, every single one of them. The only thing that's different is that the signs have to correspond with the quadrant that they are in. So if I memorize what 30 degrees is, I can reflect it and put it in the correct quadrant. Every single point will be root 3 over 2.5, just with different signs, negative positive, negative negative, and positive negative. So we're going to do this for 60 and for 45 as well. Okay, so back to our special triangles from 20-1. We have the 60-degree reference angle. So again, to put it into the unit circle, the radius becomes half as much. So I divide everything by half. So this time x becomes a half, so half of 1, and y becomes half of root 3, which is root 3 over 2. So this point on the unit circle at 60 degrees has coordinates of x, y. Along the x, it's a half. Along the y, it is root 3 over 2. So let's see if the same properties happen. So cosine of 60 is a half, and that's still my x coordinate. Sine of 60 is root 3 over 2, that is still my y coordinate. And tan of 60 is root 3. Well, let's just check that. Tan of 60, since the denominators are both 2, is the y coordinate numerator over the x coordinate numerator. Root 3 over 1, yes, is root 3. So it looks like it works. So again, for this unit triangle, cosine of 60 is my x coordinate, sine of 60 is my y coordinate, and tan of 60 is the ratio of y over x. So what we're going to do is the exact same thing. We're going to take our initial point here, and we're going to reflect this throughout the unit circle. So the first point, 60 degrees, is x, a half, and then y, root 3 over 2. Okay, so we're going to take that, we're going to reflect it horizontally, and now I'm in quadrant number 2, so my points are negative, positive, so still a half and root 3 over 2, but negative and positive. My angle, I have not reached 180, I fall 60 degrees short, so my angle here is 120. Then I reflect this in the x-axis, so it becomes in quadrant number 3. So my point still has a half and root 3 over 2, but because it's in quadrant 3, it's now negative, negative. So let's figure out our angle. We've gone all the way to 180 plus an extra 60. So my angle is 240 degrees. And then let's reflect this triangle in the y-axis. So it becomes over here in quadrant 4. So it still has coordinates with a half and root 3 over 2, but because quadrant 4 is positive and negative, so is my point. So to figure out my angle, I'm going all the way around the circle, and I didn't reach 360. I was 60 degrees short. So 360 take away 60, 300 degrees. Okay. Because we now have 4 points, again, cosine of 60, cosine of 120, cosine of 240, cosine of 300, sine of 60, sine of 120, sine of 240, and sine of 300. Again, tangent is the ratio of the numerators. So tangent of 60 is root 3 over 1, numerator of y over numerator of x. Tan of 120 is going to be root 3 over negative 1. Tan of 240, numerator of y over numerator of x, and tan of 300 is going to be numerator of y over numerator of x. And of course I would go back and simplify those. Okay, so again, with 60 degrees, every one of the coordinates is a half and root 3 over 2, and you just place them in the quadrants with the correct signs. Okay, last one that we need to do is 45 degrees. So let's go to our 45 degree. This one's a little different because the hypotenuse is no longer 2, it's root 2. So again, I want to fit it into the unit circle. So I want to take root 2 and fit it into a unit circle with a radius of 2. So this hypotenuse is root 2 bigger than 1. So I need to divide everything by root 2. So I'll divide 1 by root 2 to get 1 over root 2. I'm going to divide this 1 by root 2 to get 1 over root 2. So 45 degrees, it cuts the unit circle at 45 degrees and it has coordinates of x and y. X is 1 over root 2 and y is 1 over root 2. So I can leave it like that, or I can rationalize and say that this is the same as root 2 over 2, which is what I'm going to do. And then I can rationalize this by multiplying top and bottom by root 2, and I get root 2 over root 2. So my tip here, what I just did, is I rationalized my denominator by multiplying numerator and denominator by root 2. So I have root 2 over 2 and root 2 over, oops, that says root 2. Let's try that again. That should be root 2 over 2. Okay, so let's look at our 20-1 triangle. So cosine of 45 is root 2 over 2, which again is still my x-coordinate. So the x-coordinate is still cosine of 45. My sine, root 2 over 2 also, and that's my y-coordinate. So sine of 45 is also root 2 over 2. And tangent is 1. So let's just check tangent by doing the ratio of numerator of y over numerator of x, because the denominators are both 2. So numerator of y over numerator of x, root 2 over 2 is 1. So it looks like it all works. So in terms of 30-1, our unit triangle, cosine of 45 is x, sine of 45 is y, and tan is y over x. So we're going to take this 45-degree triangle and we're going to put it in the unit circle. So because you guys get the idea of the reflections, this should not be that hard to do. So 45 degrees is root 2 over 2, root 2 over 2. And then I'm just going to go through and reflect these all about. Okay, so let me just fix this up here. Just a second. My technology is not working. Let's try this again. There we are. Okay. So looking at this here, here's all my reflections, because we've done the reflections so many times, you guys know the drill. So, and of course I just faded it out. Okay, let's try this one more time. There we are. Okay, so this point here has coordinates negative root 2 over 2 and positive root 2 over 2 because the quadrant that it's in. The angle, I've gone almost to 180, but I'm 45 degrees short. So 180 take away 45 will be my angle in quadrant number 2. So this is going to work for all of them this way. So this one here would be 135 degrees. Okay, in this quadrant here, it's going to be root 2 over 2, root 2 over 2, but because it's in quadrant 3, they're both negative. So in this one here, I've gone to 180 and I've gone past 180. I've gone 45 past 180, so this is 225. In quadrant 4, the coordinates are still root 2 over 2 and root 2 over 2, but because it's in quadrant 4, it's positive negative. Now for my angle, I've gone all the way almost to 360, but I was 45 degrees short of that. So 360 take away 45, 315. Okay, so for this one here, all of the coordinates are root 2 over 2 and root 2 over 2, just with respect to the quadrant they're in with the signs. So let's just go around the unit circle here. Cosine of 45, here is cosine of 135, cosine of 225, cosine of 315. And then sine of 45, sine of 135, sine of 225, and sine of 315. Tangent is going to be the ratio. Now notice that the numerator of all of these are the same. It's root 2 over 2, root 2 over 2. So tangent is just going to go between 1 and negative 1 depending on the sign. So tan of 45, root 2 over 2 over root 2 over 2, 1. Over here for 135, root 2 over 2 over negative root 2 over 2 is negative 1. And here, tan of 225 is going to be a negative over a negative, which is positive 1. And tan of 315 is a negative over a positive, which will be negative 1. So let's put it all together with what we did. Putting it all together, look at this beautiful unit circle. Okay, so right now we have a whole bunch of coordinates just using our 20-1 triangles. So all the way around. Now, to remember which one is which, whether x is cos or y is cos, I always just remember they're in alphabetical order. Just like my coordinates are in alphabetical order. They go x and then y. On a unit circle, they go cos and then sine. So a point on the unit circle is tied to an angle. The x coordinate is cosine of that angle. The y coordinate is sine of that angle. All you really have to do is look at your coordinates in quadrant number 1 and then just place them in the correct quadrant, negative, positive. They all stay the same. Negative, negative, positive, negative. Those all stay the same. I'll have more videos on my YouTube channel as to how to memorize the unit circle and also how to put that into your graphing calculator. So look for those. So to summarize this lesson, points on the unit circle satisfy x squared plus y squared equals 1. And using those reference angles, we created 12 special triangles all the way around the unit circle with 12 different quadrants. Okay, each point on the unit circle has an x value of cos, a y value of sine in alphabetical order, and 10 is the ratio of numerator of y divided by numerator of x. Have you ever wondered why circles are so hot? Well, because they're 360 degrees.